and error control. That is the question. Let me repeat it, because if you have not understood it, then you might be looking for the wrong answer. But that is the question. By the way, I hope you understand that there is a difference. I hope you see the difference. And the question is, why is there a difference? So think about it some more.
Yeah.
And take it seriously, because now might begin to think that you're not serious. Might begin to think you're not serious. And this is to the rest of the class. That question needs an answer. And it's not an answer that I have not talked about. I think I took 2 whole lessons talking about that. One lesson we started, we never completed because I got disconnected. And when I came back the next time, I went over it again. Roman, what is your question? The solution to what? Mm-hmm. Mm-hmm. Yeah, the solution to half open connections. And I told you that you should find out, how does TCP deal with half open connections? I find it hard to understand that you say you have read, but you haven't found an answer. But I will excuse you and assume maybe you haven't quite taken it seriously, just like I've told Nyamao. Maybe you haven't taken it seriously because that answer is there. And the textbook that I was told has been given in class, that textbook is quite comprehensive. I'm sure I've seen that topic in that textbook. So obviously there's an answer, but you haven't looked. So let's try again Monday. And by Monday myself, I will have checked that textbook because I have a copy myself. So Monday, we'll talk about it. And this is on a serious note, and again to the class. Now, I've seen some people in class whom I have not seen for a long time. I suppose now they're getting ready for the cut, so they're attending class, right? There's some people who've made it their habit not to come to class, but today they are there. Amazingly, they are there today. If I manage to do my analysis of class attendance, some of you would not be allowed to do my cut. If I manage to do it, I think I'll ask the technicians to do an analysis of all my class attendance, because I have them. And some of you are missing the mark, because you're supposed to attend at most 64. At least 64, not at most. So just be aware that I'm keeping attendance, in case you are not aware of it. Okay, so Roman, are we agreed? Yeah, that answer is there. I believe I've seen it somewhere. Okay, so let me go back to what we discussed last time. We were trying to find some answers to some questions. And I believe those questions have not been answered yet. So hopefully today we will find the answers to the questions you are trying to answer. Okay, so let me take you back to where we were. Right, those are the questions we are trying to answer. Remember, we have talked about multiplexing and demultiplexing and how it happens. So I hope you remember how we said multiplexing is done. But now the question is, how many connections does the transport layer actually multiplex and demultiplex? How many? In practice, how many does it multiplex and demultiplex? Now, in order to answer that question, we have to find out the answer to the two sub-questions. How many clients can a TCP server connect to? And how many connections can a client have to a single server? So in order to answer the first question, we have to find the answer to the others. So I think we were on our way to finding the answers. So this is the outline. I had to insert this so that it makes it easier to understand what we are doing. So last time we talked about how to set up connections using ports. Then we talked about multiplexing using ports. And then we talked about passive and active ports and how they're related to connections. But I think what came out in those three topics was, how do you identify a connection? I think that was the main idea. When you set up a connection, what information is kept to identify that connection? Remember, we are dealing with a process. It's a program. It's not a human being. Like I can ask you, how do you know it's a connection? It's a program, so it must keep some data about that connection. So the question was, what data does it keep to identify the connections that are being made? And the answer to that question was, you need to keep 4 items. Remember that a connection is between 2 ports. Each port is identified by a composite address. So if you have port 1 and port 2, and they are forming a connection, then that connection is identified by those 4 items, the 2 composite addresses. So in other words, the source port and the source IP, the destination port and the destination IP. Obviously, a connection, there's one that actually creates the connection. So that one is the source. The one that is being connected to is the destination. So the composite address for the one creating the connection is referred to as the source port and the source IP, that composite address for that port. The destination, which is accepting the connection, is referred to as the destination. So the port there is referred to as destination port and destination IP. So ideally, we said you require those 4 items to identify a connection uniquely. Now, why are you even making an attempt to identify a connection? Because at any one time, you can have multiple connections. You can have multiple connections. Remember, we said you can run so many applications on your computer, and each of those applications may be connecting to a different server. So at any one time on your computer, if you're running many applications that are accessing things over the internet, you are likely to have many connections. And you need to identify them uniquely. So that's why we are trying to say then that those 4 items are enough to identify a connection uniquely. So that was really what we talked about last time in those first three bullets: setting up a connection using ports, multiplexing using ports, and passive and active ports and connections. So we were now just to find out about the maximum number of client connections and the maximum number of server connections. So I think I've underlined it in red. Notice the last bullet there. Source IP, source port, destination IP, and destination port are highlighted in red. In other words, that combination must be unique for each connection. And again, we said that on the multiplexing side, that combination of items is enough to multiplex and to pass that data that has arrived to the correct application. Because on the destination side, it will identify uniquely which program, which connection it is supposed to pass that data to. Okay? Then on the passive and active, we said typically the server is passive. Typically, the server is passive. Sits there, listens, and waits for a connection. Now, the important thing there is that the server listens on one port. When you have a server program running, remember, if it's a web server, it's listening on port 80. If it's a web server, it's listening on port 80. If it's another server, it's listening on a different port. And remember, let me remind you again, I have asked you many times that you need to know the port numbers on which the common applications we deal with on the internet, on which port numbers they listen. That's an assignment I've given you many times, and I know unless I say it's a cut or unless I say you submit, most of you don't take it seriously. But please take that one seriously. You need to know the port, those well-known port numbers. You need to know them. Anyway, for the web server, it listens on port 80 and so that's the port that it receives connections on. So the important thing here is that you have a single server listening on a single port. And then we have millions and millions of users connecting to this one server, which is listening on one port. All the connections come to this port from wherever they come. And so we are saying that on the server side, those 4 items, again, the source IP, source port, destination IP, and destination port, need to be unique for each of those connections, because remember that information is kept by the operating system. For every connection opened, some information is kept. But those 4 items need to be unique for every connection made to the server. Now, on the active side, remember we are saying that it is the client that makes the initial request for a connection, because the server never does it. So assume that we have a client here. initiating a connection to the server. It is usually referred to as the well, the active one. So the port that it creates is referred to as the active port. The port that the server listens at is the passive port. But either way, on the client side, it also, or the operating system must keep information about a connection that has been created on the client side. And again, the operating system must keep those 4 items: the source IP, the source port, the destination IP, and the destination port. And if the client, and here we are referring to the client machine, may be referring to the client machine. So assume all these connections are coming from your computer. You have opened many applications, and they are all talking to the same server. The question is, that each of those connections must be unique. They cannot have a combination of those 4 items which are the same. It's not possible, it's not allowed. Because those connections must be identified by the operating system. Remember, the operating system, the one that does the multiplexing. And we said for every connection, it will put both the source port, the destination port, and whatever it puts will identify the application that has sent that data. So each of these connections must have a unique ID. I don't really think it's called an ID, but that tuple that consists of source ID, source port, destination port, and IP must be unique for each of the connections made, if those connections are coming from the same computer. They must all have different values for those 4 items. So if you look at that diagram, we have several clients connecting to a single server. So if you look at the second bullet there, those items written in red there, you notice that if they are coming from this, okay, let's just assume they're coming from the client side, then they're all talking to the same server. So that 4 tuple with those 4 items, the server port and the server IP address will be fixed for all the connections. They will have the same value. I hope you see that. All those clients, all these clients on this side, each of them is, the operating system is keeping those 4 values. For all of them, the server port and the server IP address will be fixed because they are all talking to the same server. However, now if they're on the same machine as well, then the IP address will be fixed. If these 4 clients are on the same machine, then again, the source IP will be fixed. So what will distinguish those connections? That's the question. Because we say those 4 values, there must be something unique about them. So the only thing that will identify the different connections coming from the same machine will be the port number. So only the port number will be variable in that case. But by being variable, then each of the 4 tuples will have a unique value. So if you think about the values kept for each connection, so let's just assume that the IP address is fixed, the port number for one connection is 1, the value of the The value of the port for source is Y and Z. So each one of them will start with X. So the only thing that will vary will be the port number. So let's give that one 2. That one will be Y, and that one will be Z. So if you have 3 connections from the same machine, those values will be the same. The only thing that will vary will be the port number. But that variation of the port number is able to make sure that each of those connections is unique, uniquely identified. That's the idea. So if you take that connection with X1, YZ, it's definitely a different connection from the one with X2, YZ. And it's different from the one with X3, YZ. X there referring to the source IP, the 1, 2, and 3 referring to the source port, the Y there referring to the source destination port or ID, and the last one referring to the destination port. So for every connection, those 4 values will be kept, and there must be a variation to make them unique. And that's how the system is able to identify them. So we've talked about the situation where the clients are talking to one server. They're talking to one server, and the clients are all on the same machine. But what if the clients are on different machines? If the clients are on different, so this is machine 1, machine 2, machine 3, machine 4. So those are 3 different computers. Then you realize the IP address for each of these computers, of course, will be different. So if we go back to the way we were identifying our connections, then in this case, you will have, instead of the IP address X, let's call it A. So IP address will identify it with A, B, and C. We'll have the port number 1, then we'll have Y and Z. Y and Z. Then the next IP address will be B. The port number will be 2. And the IP address will be Y and Z. And so this one will be C, 3, and then Y and Z. So the idea is that at any one time, you need to be able to identify the connections. And remember that these are the same values that the server will also keep. So at the server side, all those 3 connections will be identified by these values. On the client side, this also will be the way the connection will be identified. So the server can never get confused about which client it is talking to. It always knows which client it's talking to because it knows its IP address, it knows its port number, and so when it's sending data, it will target a specific client. So anyway, I have repeated myself because I said all those things last time. Now, the question we want to ask is what is the maximum number of client connections? Assume you are running programs on your computer. I don't know if I've erased those diagrams. I don't know if I've erased them. So assume these programs are running on a single computer. The question is, what is the maximum number of connections you can make to a single server? from your computer? Yes, somebody has an answer.
The maximum number of ports is 65,000.
Why? How did you reach that conclusion?
Because since each tuple has to be unique and they're all
Mm-hmm.
coming from one computer, one client, that
Mm-hmm.
means the differentiator of each tuple will be the port number. And as
Mm-hmm.
we know, there are a set number of ports, which is a power of two, that comes to like 65,000.
Uh, okay, I agree that if they're coming from the same machine, we said already the source IP is fixed. And the destination IP and port are also fixed. So the variable is the
It's
port
a port
number.
number. Yeah.
So how did you arrive at 65,000? You haven't told me. You've just come up with this number.
Isn't that the maximum number of ports?
How do you know?
Oh no, previous knowledge.
We could previous knowledge. Where did we talk about it? But
I
there
can't
has to
remember.
be a way you arrive at that, and that way is you need to know. Somebody who thinks they know? Yes. Craig, I can
So
see your hand after Bikuri. Yeah.
yeah, so what I think the answer is,
I can't hear you, Craig.
can you hear me? I'm
Please
speaking.
speak loudly.
So can you hear me now?
Yeah, now I can hear you.
Yeah. So what I think it's like the all of the ports in a computer that it can handle is that 65,536. So I think it's that minus the ports that are already being used minus the
By
ports that have
who?
been
Already being
blocked
used by who?
by the machine
What?
itself. So that it
Oh.
means that it can't start creating a connection on a port that
Mhm.
is already being used.
Obviously. So let's assume you've started one program, and that program is making a connection to a server somewhere. The operating system will give that program a port number. Let's say port number 1.
Yes.
If you open another program, obviously the operating system can't give that program port number 1. It will give it
Yes.
a different port number.
True.
So all the time, the operating system will give port numbers and make sure that they are unique. Okay, so it cannot repeat the port numbers.
Yeah.
But, so what is the maximum?
So I think the maximum is a variable number, and it will depend on those variables.
No.
That's what I think at the moment.
That's what you think.
Yes.
Okay, right. I think what you have forgotten, was there a third person? I think there's another hand. Makoha Wisdom. Makoha, are you there?
Yeah, I am here.
Yes, I can see your hand is up.
Okay, what I think is since a connection is identified by the source IP address, the source port number, and the destination IP address and port number,
Mm-hmm.
the server can have as many connections as it can, the resources can support,
Mm-hmm.
because the client IP addresses are first of all different, because for each client there is a high chance that they all have a different IP address and port number. And for the server, okay,
Mm-hmm.
assuming the server is the same, it's because the server IP address and port number will all be the same, but the client IP addresses and port numbers will be different, it is possible to
Mm-hmm.
support as many connections as the server can manage with its resources.
Yeah, but you see, you are answering the second question. The first question you're answering is, how many connections can a client make to a single server? You are answering the question, how many connections can a server accept? I think that's the question you're answering. How many connections can a server accept? First of all, remember here we're talking about a single machine making connections to a single server. But think about all the machines in the world, and anyone can open as many programs as they want on their computer. So if you have 1 million people connecting to the server will have 1 million times 65,000, which is what you're all saying. But you have not given me a justification for why it's 65,000. So wisdom, let's come back to you when we talk about the server side. How many connections can a server accept? You know, we always connect to these servers, like you connect to a web server and you have no idea there could be millions of other users around the world connecting to the same server. And the question is, how many connections can be made to a single server? Practically, and we have billions of computers around the world. What if they all decided to talk to a single server? Just imagine that scenario. Can the server accept all those connections and service all those connections? Okay, but let's leave the server side for the moment.
Okay.
Let's just think of a single user. How many connections can they make? Okay, let me put it this way. You are all right. You said 65,536, but the reason behind it is what you don't know. So take one last person. Okay. And I remember you had questions for me last time. I told you to wait until we reach here. So
It's just I would say because of subnetting and networking, the number 256 comes to mind, which is something about the octating of subnet masks. So if there's a client and a server, I just thought if you square 256, because you have to account for both sides. So you square the 256 bits, you'll get 65,536.
you squared 256 bits. Okay.
Yes.
But you just don't square. There's a reason behind it. And okay, let me ask you this question, because that's really the reason behind it. Okay, you are right that it is 2 octets. But I think to get the answer to this question, you have to go to the header of the transport segment. How many bits are there for the port number?
16.
16.
16, exactly. So that means if you are sending port numbers, you cannot send a port number greater than 2 to the power 16. Where will you put it? It's only been given 16 bits. That port number has only been given 16 bits. So a segment cannot carry a port number. You cannot put a header on some data with a port number greater than 2 to the power 16. So that's where it comes from. Does it make sense?
Yes.
Yeah. If it was greater than 16, maybe you can use port numbers more than that. But if that's the space you've been given, then you can only carry port numbers from 0 to 65,535, because obviously it will be one less, since you always start from 0 to the last number. So the last port number will be 65,535. But in total, there are 65,536 possible connections. So remember, when we're talking about multiplexing, We said that when data comes from an application, it is passed down to the transport layer. Then the transport layer will add a header to it. It will put the source port, it will put the destination port, and then it will pass it down to the IP layer and so on. So when it is putting the source port and the destination port, they have to fit within those 16 bits. Which means the operating system, when it's creating ports, cannot go beyond that 16, or should not go beyond. Let's just put it that way. But of course, I know you will ask a question later, but for the moment, let's just stick to that. So if that is the case, then it means you can start a maximum of 65,536 programs on a single computer, each one of them connecting to the same server. Now, of course, practically, most of us don't even reach that number of programs on a single computer. I doubt anybody has opened 65,000 programs on a single computer, but it's a large space, so you can open many programs if you wish. So that answers our first question. How many, what is the maximum? Is there a maximum? And we found that there is a maximum. Definitely there's a maximum. But that maximum is way beyond most of us, what most of us will ever even think of doing. So it's a good maximum. So now we go to the second part of the question. Now, I'm not sure what I have said here, but obviously you say that a TCP port field is 2 bytes. And so because of those 2 bytes, we have 65,536 possible port numbers. So we can make 65,536 simultaneous connections to a single server. And those port numbers, of course, as I've said, will vary from 0 to 65,535. Now, notice, if a client machine has a single IP address, then you can have 65,535 connections on that single IP address, because remember that IP address will be fixed. But the question is, what if a computer has more than one IP address? So let me go back to those tuples that I was talking about. So let's assume the IP address is fixed. So it is X, 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 okay? And on the server side, of course, we have Y and Z. But the question is, if on the client side, you have more than one IP address. Of course, most of us don't have more than one connection, but you know that there are computers that can have that. So let's assume we give it S. The IP address will be S. So how many connections can you have? If these ones can be 65,000, these ones are 65,000, you can have a maximum. So this one can be 65,536. Now, of course, if you use S, you can also vary from 1, 2, 3, and Y and Z will be fixed. And all these connections will be unique. They are all on the same computer. Only that the computer has 2 IP addresses. And if you use those tuples, then you can have how many unique connections on a single computer? Remember that the operating system keeps the data structure which stores these values. So as far as the operating system is concerned, each of these will be your unique connection. So notice that on that slide, it says 65,536 connections per IP address. That means that if the computer, the client computer, okay, or if these connections are coming from a given office, and that office has several source IP addresses. Of course, you remember the issue of the network address translation. I hope you remember that, where you have private IP addresses, but when connections are going outside, then you use a few IP addresses, public IP addresses. So let's assume this office has several public IP addresses, and computers within the office are trying to make a connection to a given server. Then the idea here is that you will have 65,536 connections for every IP address. That's the maximum. So you can really ideally, potentially, depending on how many IP addresses you have on that computer, you can potentially make more than 65,536 connections. Now, the question of how the operating system does it, now that's something maybe I should ask you to investigate as you do this reading. We're talking about Roman, remember? Put that as a question to the class. How does the operating system manage this? Because potentially the idea is to identify connections. So how does the operating system do that? Since it knows that that computer has multiple IP addresses, it needs to uniquely identify each connection based on that four tuple, what do you say, information. So how does it really do it? So let me leave for you that as an exercise or as something to ponder, how practically it's done. But the issue here is that 65,000 is a limit on a single IP address. Okay? And notice there that I've said a client in brackets or office. I've explained to you something that I believe you're familiar with from the other class about the network address translation, so you'll be able to understand that. But investigate that and find out how it happens. Maybe next time you'll tell me. Okay, I believe that is well understood. Now we go to the server side and we are trying to ask, how many connections can a server accept? And I think Wisdom was trying to explain. So let me try and draw it now. Let me try and draw what the question we are trying to answer. So here is a server, and most of the time we interact with servers without thinking. You just see yourself as the only one who needs something from a server. But what we fail to remember is that out there are many people who are accessing that server. Any single server on the internet may have several users. So let me assume these are users. This is user A with their own computer from which they can make 65,536 connections to this server. This computer can make 65,000 connections to this server if they want. This one can equally make 65,536 connections to that server, and so on. Now the question is, remember the server is listening on port 80. If it's a web server, it's listening on one port number. But we said that one problem that the server must solve is how does it identify all these connections? Now, from what we've said, because each of these user machines has a different IP address, so assume that's the IP address is X, this is Y, this is Z, and this is V. So you can imagine that the connections will be different. And those connections will be identified by the same values on the server side. So the server has no problem distinguishing those connections. They'll be very different, very unique as far as the server is concerned. But now the question is there a maximum, do you think? Is there anything that can prevent the server from connecting to 1 million users or 10 million users? And by now, I hope you understand why the specs of a server are typically very high spec. Because imagine you're accepting 10 million connections from all the computers on the internet, and you're able to serve them within very short period of time. What kind of CPU do you need? What kind of memory do you need in order to do? And remember, we said once you open a connection, once a connection is opened, it's for transferring data. One user may be transferring a file, one may be transferring video, one may be transferring all kinds of things are being transferred on these connections. So the specs of a server typically need to be very, very high, anticipating the kind of work it will do, the number of users it will serve, and so on. But let's come back to the question. What is the limit? Is there a time the server will say, I've reached the limit in terms of the number of connections? Or is there a time those values you may find you cannot uniquely identify the connections being made? If I increased it from 1 million to 10 million, will the server still be able to uniquely identify each connection? If I move it from 10 million to 1 billion, will still each connection be uniquely identified? Let me get some answers. What do you think? Because the idea is to uniquely identify those connections. Is there a limit? Yes.
So
Right.
yes, so I think there shall be a limit based on the server system resources, and also maybe if the server they have put a configuration to actually limit the number of connections.
Okay, let's talk theoretically. Let's assume you are using some supercomputer. Your server is a supercomputer or a cluster computer, one of the most powerful computers in the world.
Okay, then the server will still be able to uniquely identify each connection, because on the client side, the operating system on the client side ensures that each connection has a unique port. And if it's a connection from a different machine, so different clients, different OSs, they'll have different client IP addresses. So all of the connections will still be unique, if it's 1 million, 10 million, or a billion.
Okay, good. So basically you're saying there's no limit to the number of connections that can be made to a server, theoretically.
Yes, if you have a
Theoretically, there is no
supercomputer.
limit. Yeah. Theoretically, there is no limit. That is the answer to that question. Theoretically, there is no limit because you can always given that the computers have different IP addresses, there will be no limit. And also assuming that you can have as many computers as you can. Of course, we know that theoretically the computers are finite. Even if there are billions, they are finite. But let's just, what we are trying to say is theoretically, assume the number of computers is not limited. Assume the server has no limit in terms of its computational power. Theoretically, there is no limit in terms of the number of connections you can make to a single server. Notice a single server, there is no limit. However, I think I had Wisdom, and now I've heard Craig saying that there is a limit when it comes to practically implementing a server. So let's talk about the limits in a practical sense. What may limit the server from accepting connections? It will definitely not be the identification of a connection. What will cause a server to limit the number of connections? Yes, Taylor.
I think the computing power of the server itself, and that's why something like DDoS attacks are effective, because you flood the server with so many things and then it reaches its limit in terms of computing power and it can no longer process anything.
Yeah, what example is that you gave?
I gave an example of the DDoS attacks where they get flooded with multiple clients.
Say that
So they
again.
get overwhelmed.
I'm not hearing that example you're giving.
I'm saying in the example of a DDoS attack where the server gets overwhelmed with multiple clients, it'll crash, but that's because its computing power couldn't handle that many clients.
Oh, okay.
So, yeah.
I understand. A denial of service attack.
Yes, yes.
Yeah. Do you know what a denial of service attack is? I mean, how would you explain it, in other words? How would you explain a
For me,
denial of service?
okay, I know there's a difference between DDoS and just denial of service. I'm not too sure on the difference, but the way I understand it is just flooding the server with multiple clients. They will usually be fake, but yeah.
Yeah. There are people out there who are malicious and may want to flood the server with all kinds of requests so that users, whoever the real users, when they access the server, they find the server is just too busy. Because theoretically there's no limit, but practically there's a limit in terms of the computational power of that machine. Even in terms of memory, it's limited by its capacity to service connections. So it will definitely reach a point where it has to cut off. Because when you access a server, most users don't want to be kept waiting for too long. So whoever is implementing the server must take that into account. And I think I heard Craig talking about some configurations. You can configure the server to say, look, when you get this number of connections, now stop, don't get any other. Because you are thinking about how many people you can serve at a reasonable speed. So if your consideration is speed, how fast you can service your clients, then you have to put up a limit on the number of connections that a server can accept. And please remember, we already said that a server is always listening. So let me put this in. If you remember, we said that a server, when it is listening, it has a queue. And in that queue will come the connection requests. So the connection requests will be put in that queue and the server will pick them one by one and accept them. So even by limiting the queue size, you're already saying if requests come and they are more than that queue can take, then they'll just be lost. So you're already restricting the number of connections that a server can accept by specifying that queue. But of course, if you don't take into account, then I think I heard Taylor saying that the performance will really degrade. And there will be no meaningful response time. It will take too long. Most users will get dissatisfied and they will forget about that server. They will go to another server. So that is something to put in mind. As you program, you need to know that theoretically a server can get as many connections as it wants, but you must take into account the computational power of that server and what it can meaningfully serve at a reasonable response time. And if you are put in charge of coming up with the specs of a server, in any server room, you must take into account the users who are going to depend on that server. So if it's for an organization, you must know how big that organization is. You must study the trends and the patterns of communication. And that's why monitoring is a good thing. If you're a network admin, you must monitor your network to find the patterns of traffic, because they guide you in terms of these decisions which you have to make. What kind of a machine do we need for our server? It must be based on something. It must be based on something. If you are collecting data, you may know how many transactions per minute you are getting, how much time each transaction takes, and so on. So you can pretty much come up with some reasonable specs based on some data. Yeah. But if you don't monitor your network, you don't monitor your systems, you will just make an arbitrary decision. And that is why, let me just interject and make just a minute. I would like to say that over time, I think some research was done or some statistics were taken over time in many server rooms or in many organizations to find out just how much of the computer is being used in these server rooms. And it was clear that most of the admins were coming up with specs that are just, you know, because maybe they were not able to estimate or whatever, maybe they were not able to get the kind of specs they needed. But most of the time there was an overestimation of what really they need. And so you'd find that most of the servers were just maybe being used, 20% of the capacity was being used because they went and bought some, you know, just very high spec servers. And so maybe if you check the utilization of the servers, it would be very low, 15, 20%. So 80% of the capacity is not being used. And I hope you know that the cloud computing is one of these technologies that was trying to solve that problem. Because now you can buy a single server and you can place on it several servers, virtual servers. So that now you don't need to buy a single physical server for each server you are running in your server room, which is what used to happen. And because of poor estimation, each of those servers was basically being underutilized. But now the cloud is solving that problem by coming up with this idea of virtualization and being able to have virtual servers. And now, instead of buying many physical servers, you just need to buy one server and create several virtual servers and run your servers on a single machine. And you go out to buy a physical server again when your current server and all the servers it's running are beyond the capacity of that particular computer. But anyway, you need to think about that when you're programming. Of course, for the programs you're running, you won't have this problem. But of course, if you find yourself in a situation where you need to program a server or you need to decide on its specs, then you put that into consideration. So I have basically said all that theoretically, a server can have 65,535, actually, and 36 connections per client. And again, here we have a server might have multiple ports. From the way we had done it before, we assumed the server only has one IP address. So we said the IP address was fixed and the port number was fixed. But what if a server is running on port 80, but it's receiving connections from multiple ports, and such a server is said to be multi-homed, either is single-homed or multi-homed. If it's single-homed, it means it has one IP address. If it's multi-homed, it has multiple IP addresses. So the issue here is that this server is running on port 80, let's assume, right? But connections will be made based on the IP address as well. So in one case, it has IP address X. A connection has been made to this port via this IP address. At another point, it has been made to this port 80, but using a different IP address, because the computer on which the server is running also has multiple addresses. So that means that you can basically have a server receive many, many more connections. But as we've said, even with a single home server, there's no theoretical limit. Now add to that the fact that it has multiple IP addresses, and connections can come through each of those different ports. Then the number of connections goes up. But ultimately, there is no theoretical limit. There's no theoretical limit. And I think that is our conclusion. So you can read the rest later. However, we said that you have to, practically, it's not possible to have a limitless number of connections because you have to think about performance. Now, performance is limited by the CPU power, by the memory capacity, and so on. So the server is only limited by those issues and not by the number of connections it can have. There is no limit on the number of connections, but it will be limited by the capacity it has. Okay, so that's our conclusion. So now let's come back to the main question. So having talked about multiplexing, and I hope you remember the idea of multiplexing, right? That you have a single physical connection, and let's just assume a single IP address. So data is coming out of that computer using that port, and then going into the internet and then getting to a destination machine. And on this machine, of course, we have all the different layers, but let's assume we have the transport layer there, and we have multiple programs running on this machine. So we have to make sure that all the data they are sending is properly labeled and comes out of this computer through this port. And we need to funnel them in such a way that we can be able to separately identify them or multiplex them so that they are all sent out through that connection, that network connection. And so we are saying, how many connections can the transport layer multiplex? And on the other side, how many connections can it demultiplex? So again, here we have several programs running and receiving messages which have to be demultiplexed. So how many? Remember, I don't have the answer to that question, but what do you think from what we've discussed? We've been talking about multiplexing, but in reality, is there a maximum to the number of connections that the transport layer will be asked to multiplex? Is there a limit? Is there a theoretical limit to the number of connections it will demultiplex? What do you think? Okay, we have a volunteer. Roman. Mhm. Mhm. Okay, let's distinguish two things. There is a connection, and on that connection, you can send several packets or segments. So are you saying there's no limit in terms of the packets you can send in a connection? That's one aspect of which you need to distinguish for me. When you're talking about multiplexing, are we talking about the packets themselves or are we talking about connections? What are we multiplexing? Are we multiplexing connections? Are we multiplexing the data? And that's a good point because it's coming out. What are we multiplexing? Okay, I agree with you, Roman. We are multiplexing connections. It's connections we are multiplexing. So if this program has made a connection, so let me put it in a different mode. So each of these programs has created a connection, right? Each of them has a connection through which it's sending data, and the data on those connections will have to follow that physical path. So we are multiplexing all these transport connections onto this single connection here, this lower level connection, physical connection, right? We are agreed on that. So the question is, how many different connections then can we multiplex? on a single computer. And as I said, I actually don't have the answer, but I want you to think about it. And remember, we said that you can multiplex TCP and UDP packets. So on the side of TCP, we are multiplexing connections. On the side of UDP, what are we multiplexing? Because
Data.
UDP doesn't create connections, does it? It doesn't. So we are multiplexing the individual packets. So if there's a program using this UDP here, it will be forwarding packet by packet. So if it has 10 different packets, it will forward one by one. So we are taking those packets that are coming out of these UDP applications or connection-based applications, and we are multiplexing them also here. Together with the packets that are coming in through the connections. So in the case of TCP, we are multiplexing the connection. So how many connections can the transport layer multiplex? As long as you remember, the UDP packets are also being multiplexed. But in the case of connections, how many connections can the transport layer multiplex?
Excuse me, madam.
Yes.
Okay. For this question, I'm not sure if what I'm thinking is correct, but correct me if I'm wrong. But to me, this doesn't look like a limitation of the transport layer. It kind of looks like more of a limitation of the channel on which you're trying to multiplex over, because like the bandwidth just goes lower and lower, the more connections are going over the channel. At least that's how I've understood it.
Okay. I think you're thinking about the physical limitation. And again, let's leave out that and think theoretically before we come to I think you're thinking about the practicality of it.
Yes.
So let's remove that limit and just say the bandwidth here is limitless. Suppose it was. How many connections can the transport layer multiplex? Taylor, would that remove the limitation you're putting there yourself?
Yeah, it would.
So if I remove that limitation, how would you answer that question?
In that scenario, I don't even think about how. I think it would depend on now computing power or something, because you'd be trying to make multiple logical connections. So it depends on, I don't know, to be honest, I don't know.
You don't think the 65,000 we have talked about comes in here? Do you think it plays a hand? You have Makoha. Makoha, what do you think?
I think there won't be a limit, because as long as the transport layer can uniquely identify whichever is for example, if it's a source program, as long as it can uniquely identify the source program, whether it is TCP or UDP, it will be able to multiplex or demultiplex, because the only point of multiplexing is taking all those connections and sending them to a single, and trying to send them over a single channel over the network. And if it can identify that each of these connections are from different, for TCP, in the case of TCP, if it can identify that these are from different programs, and in the case of UDP, as long as it just gets the packet, it doesn't. I feel okay. I think there is no limit in how many connections, whether it's TCP or UDP, that can be supported by the transport layer.
Okay. So you think the 65,000 we are talking about has no part to play here?
It has the 65,000 connections is only a limit on the when using TCP protocol, but when UDP comes into play, the limits are only imposed on the side of TCP. Maybe for UDP there are other perhaps I'm forgetting something about UDP, but UDP, if I remember, there are no connections or anything, so there is no uniquely identifying factor within UDP packets which will limit the number of connections that any program can, I mean, not connections, the number of packets that a UDP protocol will be limited to use to send.
Mhm. So you think we can have limitless number of UDP programs?
Yes.
Okay. But don't you think that, remember, every packet that leaves a computer will have, every packet will have to have, at the transport layer, it will have to have a source port. The source port will have to be marked with a number. And that number we said is 16 bits. So do you really think we can have a limitless number of UDP programs? Because each of those programs must have a port. Remember that before a program begins to communicate, it must create a socket. And then it must have an address on that socket. And that becomes its composite address by which any program wanting to talk to it must talk to it through that composite address, which consists of the IP address and the port number it's using.
Yes.
And when the packets are being sent, each packet must contain the source port number, which is 16 bits. So do you really think you can have a limitless number of UDP programs?
I'm not so sure now. Let me think on it.
Yeah, you need to think about that, because I think there is still a limit. That port number, that 16-bit port number is a real limit, whether it's UDP or whether it's TCP. Now, another thing you need to figure out, and again, Roman, I give you this as a question which you need to pose to the class. When the operating system is creating these programs, some of them are UDP, some of them are TCP, does it use the port numbers from 0 to 65,000 for all of them? Or does it use 0 to 65,000 for TCP and 0 to 65,000 for UDP? Roman, have you understood my question? I'm saying, how does the operating system behave when it's running TCP programs vis-a-vis UDP programs? Does it just say, I have a limit of 65,000 programs I can run, so whether it's UDP or TCP, I'll just give any one of the numbers from 0 to 65,000? Or does it have 0 to 65,000 for UDP and 0 to 65,000 for TCP? Yeah, I want the class to go and find out, so that we will say that on one computer, you can only run a maximum of 65,536 programs. Or is it 65,000 for TCP and 65,000 for you? Because the limit of 16 bits applies. So does it apply across the board, or does it apply only per type of program you're using. So I hope you will find the answer for me next time. But personally, I think the 65,000 we're talking about has a part to play here. Because if I'm limited in terms of the number of programs I can run and can make maybe it's only those that can make connections. But either way, your program will use TCP or UDP. Either way, you will not write a program that doesn't use TCP or UDP. You have to choose, but it has to either use TCP or UDP. If it's running on top of the transport layer, it will be one of the two. And that's why that question I've given you to find out will be very important. So will you be limited by 65,000 for the combination of both? But either way, you'll be limited. So if it's 65,000, then that's the maximum number that the TCP can multiplex. I hope you're getting my argument. Every program that runs on your computer must have a port number. And the 16-bit will bring a limitation. Secondly, every program that runs must choose to either use TCP or use UDP. It can't be anything else. It must be one of those. And the segments they will produce will be given numbers based on that limit of 16 bits. So either way, the 65,000 applies here. So there seems to be a limit, which means whatever that limit is, that is the maximum number of connections that the transport layer on any machine can multiplex. Okay, I think it's something to think about. I liked what I think it is Taylor who brought out about the denial of service attack. That's something to really think about. It's something to really think about when you're dealing with connections. So now the next topic we are going to look at, and I know time is up, but I just want to bring it to your attention. And I want you to read, because now we finished with the transport layer, remember? So now we are moving now to start programming. So now we are on the API, we are on the transport API. So we stopped looking at what happens underneath. We stopped looking at what happens at the transport layer. So now we are above the transport layer. So we are really programming right now. We are starting to program or to use the actual transport service. And that's why here, this topic is about transport layer service primitives. Basically, an API is provided by the transport layer, which programmers can use. But from what we've said, either the programmer will be using TCP, where the program creates a connection to whichever program it wants to talk to, or the program will be using the connectionless version. Those are the only two options that the transport layer provides. Now, of course, if you're using the connection version, then you need to look at that diagram that we talked about. I don't know if I have a copy here, but look at the title of look at the title of that set of slides, and we will not go through all this. This is an important thing. So these are the primitives we are talking about, which we said are the things you need to know in order to program. So this is the API that is provided by the transport layer. So you need to know what each one of them does, what variables it takes, what it returns, because it's a function you call and you get back some results. So that's what we are going to look at. The minute we do and finish this, you're good to go. You're good to go in terms of programming. So my hope is that we will finish this on Monday. And then now it will be about programming and more programming. I think I've given you enough programs to write. So you don't even need to wait for me to tell you what to program. The programs I've given you to program, they are from number 1 to number 6. They're enough to keep you busy until the end of semester. Okay? So I think the Monday class will be important. Unless, of course, you already understand these primitives and how they work. And if you do, then you should go ahead and program. If you need some explanation, then please make sure you attend the Monday class. On top of that, so we are going to be focused on Berkeley sockets. And I think I asked you for that textbook, I asked you to download, we talked about BSD sockets, which is what Berkeley sockets are all about. I think there's another version, but I think we won't use that. So that's what we'll focus on. But before we do that, so I want you to skip this whole part. This part on transport protocols, you can read it on your own, but I won't go through it in class. The part I will go through is this one, which is also important. Because I have said the operating system keeps some data about every kind of connection that is created. And these are the data structures that it keeps. So please, I will go through this on Monday very quickly, but I would like you to read this before then, because then it will give you an idea of what the operating system knows about each program. Notice here that it keeps this information about every connection that it creates, so that it fully knows the local and remote IP, the local and remote port numbers. So we will go through that, and then we will also look at this data structure for IP addresses. So please read before then, but I'm hoping that Monday, after Monday, you're good to go. So the only thing then we will do after that is those reading assignments. Those reading assignments that I gave you, we will begin to discuss them after we start programming, so that they will be applicable to you as you program. So now I will start dividing those assignments and ask different groups to present different parts of those reading assignments. Now, Monday, I've already explained what we'll do. Friday, we have a cut. And that cut will include everything, including what we will discuss on Monday. Everything we have done since we started until the API interface, which we will look at. The API for the transport layer, which we will look at on Monday. So please prepare yourself for the cut on Friday. Any questions? Is Oko still in class?
Yes.
There was a question you asked, and I asked you to wait until we discuss that part we just talked about, the number of connections and so on. I don't know if it was answered or not.
Yes, I followed up and actually I got an answer to the question.
You did?
Yes.
Okay, personally, I don't remember the question anymore, but if you answered, that's okay.
Thank you.
All right, so let's meet on Monday and have a good day.